All right, now that we've explored a little bit about polar coordinates and how they work, now let's talk about polar equations and what their graphs look like. Some of these are basic, lines and circles, but then we get into some really cool ones that look like hearts and flowers and those kind of things. So let's start with just the basic ones, and let's just write up here the things we're going to need, kind of the ammo we need for this section. We need to remember that y is r sine theta. Excuse me. We need to remember that x is r cosine theta. And we also have to remember that tan theta is y over x. So that's going to help us kind of convert back and forth pretty quickly. Okay, so for lines, now I'm not talking about vertical horizontal lines. I'm talking about oblique or slanted lines. So if you picture the pi over 4 ray, if you can picture it kind of cutting through the circle, excuse me, you can kind of picture it as being slanted, right? And like part B, pi over 6, slanted. All right, so now the trick with these, the one trick we try, is we take the tan or tangent of both sides. Okay, so it's like multiplying both sides by 5 or dividing by 3. We take the tan of both sides. So if I take the tangent of both sides of part A, I would say tan of the left, which is theta, is tan of the right. Okay, then we say, all right, I need to turn this into x's and y's. So tan theta is the same as y over x. And tan pi over 4, which is 45 degrees, is 1. And then take my x and multiply it up. Look what I have, y equals x. That's definitely the equation of a slanted line. And on a quiz, I'll have you sketch it. So this would have y-intercept 0 with slope up 1 over 1. So here would be the equation of that line. Now, I don't want the whole circle here because you're only graphing x's and y's, which are rectangular. Okay, let's try another one where the numbers aren't so pretty. So part B, if I take the tan of both sides, I get tan theta equals tan pi over 6. All right, so same deal. Tan theta is y over x. Tan 30 degrees, when I rationalize it, would be root 3 over 3. Then I multiply my x up, and I get root 3 over 3x. All right, that means sketch a graph. Y-intercept is 0 still. Up root 3 over 3. There would be my slanted line. Okay, and again, only x's and y's that we're graphing. All right, now let's talk about a couple that are vertical horizontal lines. Okay, r sine theta. Hopefully that's starting to ring a bell. That's the same as y. And then just 2. So that's kind of a nice easy one. That's just a horizontal line at y equals 2. All right? And then part D, r cosine theta is the same as x equals negative 3. So you've got a vertical line at negative 3. Okay? So those aren't super special. They're just lines. We've graphed lines. This is just another way to graph them. But make sure you know those. They will come up in homework quizzes and tests. Okay, now let's try another one. Let's try circles. Okay, so for lines, we could take the tan of both sides, or like C and D, we can turn them into x's and y's right away. Well, how about 2a? If it's a circle, and I just tell you the radius is 3, but I want the equation of it, the trick on these guys is to square both sides. And that comes up a lot. I think we even did it in the last section. Okay, so square both sides. So if I come in here, and I square it, I get r squared is 3. Oh, sorry, 9. And then I think, okay, well, r squared is the same as x squared plus y squared. Oops, x squared plus y squared. So there's my equation of my circle, and hopefully you go, oh yeah, that means it's centered at 0, 0, with the radius 3 all the way around. 3, 3, 3, 3. There's my circle. And on quizzes and tests, these would be non-calculator, and they would just be rough sketches. Okay, so you do a really rough sketch of part B for me, and then we'll move on. Okay, so we took the tangent of both sides. We squared both sides. Now a trick on part C and D is, how about if we multiply both sides, multiply by r. All right, let's see what that does for us. Look at part C. If I come in here and I multiply everything by r, here's what I get. R squared equals 4r sine theta. Okay, well, looks a little bit messier instead of cleaner, but now let's take a closer look. R sine theta is the same as y. r squared is the same as x squared, x squared plus y squared. Oh. All right, so now I have an x squared plus y squared equals y. So, or 4y, excuse me. So now I go, oh, that's a circle, but it's not ready to graph yet. I have to actually complete the square for this one. So I'm going to keep my x squared here and my y squared right next to it, and I'll subtract my 4y over. All right, now you probably remember completing the square, but let's just review real quick. We'd add a 4 here for the y's, and we'd add a 4 here. So my completed square would look like this. X squared plus y minus 2 squared equals 4. All right, now I wrote a little bit too big, so I'm doing a little baby sketch down here. Okay. So I have, oops, sorry, I didn't mean to do a circle. Hang on, let's back up. Don't look at that one. Okay, let's do it right here. Okay, so the center of the circle is at 0, 2. 0, 2, so here's the center of that circle, with radius 2. So that means I'm going to go 2 in every direction. Now, if this were perfect, I'd have graph paper and everything, but that would be a rough idea of that circle. Okay, now, hopefully you didn't write quite as big as I did, so now you try part D. All right, now this is kind of the cool part of this section. We're going to do a lot of these on the calculator together in class, but just so we can get the idea going, I'm going to do a few of these chart by chart. So we'll do a couple kind of really nice and slowly, and then I might leave you on your own to try a few more. Okay, now we're going to get into some really cool shapes, and these are mostly French names, so if you take French, you can help me with the names. But the first one I can say, it's cardioid. Maybe that's not perfect French, but that's the idea. And cardioid would be a heart. So we're going to have an upside down heart, right side up, left, right, but our shape at the end of this should be a heart. Okay, now before we do anything with the chart, you do have to graph this equation. Oops, let me circle it. As though it were in rectangular. That's how we fill in the chart. So you're doing it by hand, and then I'll allow you to check on the calculator, do the checking in class together, because there's a lot of buttons I need to talk you through. Okay, so if I'm thinking back, way back, I don't know, chapter 6, I think it was, when we learned how to graph sine and cosine. The 1 at the beginning of this one means up 1. The negative means upside down sine. Okay, so I'm going to start. Let's just review graphing kind of quickly down here. And pi over 2, and 3 pi over 2. Okay, so regular old sine with amplitude 1. And this guy's upside down because of the negative. Would look something like this. All right, regular sine, but upside down. All right, then I'll come in, maybe in orange so you can see a little better. I'm going to bump all those points up 1. So these are the ones that are actually going to go in my chart here in just a minute. So let me make them kind of nice and big and very clear. As clear as I can. All right, so I graph those. Okay, now, you can see that's not a whole lot of points. So I'm going to put those in my chart first, and then we're going to pick what kind of makes sense for more points. Okay, so my thetas that I just chose, because of just sine, I chose 0, I chose pi over 2, chose pi, I chose 3 pi over 2, and 2 pi. Now I need a couple more, and we're going to use numbers that are easy to identify. For instance, sine of 45 would be root 2 over 2, wouldn't it? It'd be a really ugly number, so that's not such a great number to choose. But sine pi over 6, if I put a pi over 6 in here, would be like sine 30. Okay, so let me write this out here. So if I want to know what's the radius when theta is pi over 6? That's the question here. So if I take my function 1 minus, oh gosh, my stylus, sine pi over 6. And again, the reason I chose pi over 6 is because it's 30 degrees and sine 30 is a half. So it's a nice, easy number. So I go 1 minus, okay, sine 30 is a half. So it's just a half. Okay, so there's one nice number. Now another nice number, it doesn't actually matter what you choose, but I'm going to use another one with 5 pi over 6, another over 6 idea. Because if you do the same thing, it ends up being a half again. So if I fill in my chart over here, it's a half for this one. Sorry guys, my stylus dying. So both of those are a half. So that's kind of nice. Okay, now let's just read our graph. If I have 0 for theta, my orange dot was at 1. Pi over 2 is at 0. Pi was back at 1. 3 pi over 2 bumped up to 2. And 2 pi was back up at 1. Okay, so these points are thetas and r's now. So now I'm going to graph those on the polar coordinates. Okay, so now let me just kind of pause this a minute and move my graph over. All right, now let's see what all these r's and thetas look like. So my first theta r was 0, 1. So you know where the 0 ray is, and then 1 would be about here. Okay? And then the next one I have is pi over 2, 0, which means it doesn't move, so it's at 0, 0. Then I have pi, 1. Then I have 3 pi over 2, 2. Then I have 2 pi back at 0. So I just kind of mapped it again, right? Okay, now remember the one we chose was pi over 6, and it ended up being a half. So we're going to kind of sneak a little half in here. Whoops, maybe, can I? Good. And 5 pi over 6, same thing, with another little half. Sneak it in. Okay, now, again, we don't have a ton of points, so that's why I'm going to show you on a calculator tomorrow. But if I connect these, and then I use my calculator to check, I end up getting this cute little heart called cardioid. Isn't that cute?